Welcome back to the Automation Podcast. My name is Shawn Tierney from Insights in Automation, and I want to thank you for tuning back in this week. Now, in this show, I actually had the opportunity to sit down with Tom Weingartner from PI to learn all about PROFINET. I actually reached out to him because I had some product vendors who wanted me to cover their S2 features in their products, and I thought it would be better to actually sit down and get a refresher on what S2 is. It's been 5 years since we've had a PROFINET expert on, so I figured now would be a good time before we start getting into how those features are used in different products. So with that said, I also want to mention that Siemens has sponsored this episode, so it will be completely ad-free. I love it when vendors sponsor the shows. Not only do we get to break even on the show itself, we also get to release it ad-free and make the video free as well. So thank you, Siemens. If you see anybody from Siemens, thank them for sponsoring the Automation Podcast. As a matter of fact, thank any vendor who's ever sponsored any of our shows. We really appreciate them. One final PSA that I want to throw out there is that speaking like I talked about this yesterday on my show, Automation Tech Talk, as we've seen with the Ethernet PLCs we were talking about, a lot of micro PLCs that were $250 10 years ago are now $400, right? That's a lot of inflation, right? For various reasons, right? And so one of the things I did this summer is I took a look at my P&L, my profit and loss statements, and I just can't hold my prices where they are and be profitable, right? So if I'm not breaking even, the company goes out of business and we'll have no more episodes of the show. So how does this affect you? If you are a student over at the Automation School, you have until mid-September to do any upgrades or purchase any courses at the 2020 prices, all right? So I don't want to raise the prices. I've tried as long as I can, but at some point you have to give in to what the prices are that your vendors are charging you, and you have to raise the prices. So all my courses are buy once, own forever. So this does not affect anybody who's enrolled in a course. Actually, all of you folks enrolled in my PLC courses are seeing updates every week now. So, and those who get the ultimate bundles, you're seeing new lessons added to the new courses because you get that pre-order access plus some additional stuff. So in any case, but again, I want to reiterate, if you're a vendor who has an old balance, or if you are a student who wants to buy a new course, please make your plans in the next couple of weeks, because in mid-September, I do have to raise the prices. So I just wanted to throw that PSA out there. I know a lot of people don't get to the end of the show. That's why I wanted to do it at the beginning. So with that said, let's jump right into this week's podcast and learn all about PROFINET. I want to welcome to the show Tom from Profibus Profinet North America. Tom, I really want to just thank you for coming on the show. I reached out to you to ask you to come on to talk to us about this topic. But before we jump in, could you first tell the audience a little bit about yourself?
Yeah, sure. Absolutely, Shawn. I'm going to jump to the next slide then and let everyone know, as Shawn said, my name is Tom Weingartner, and I am the Technical Marketing Director at PI North America. I have a fairly broad set of experiences ranging from basic hardware and software design, and then I've moved into things like avionic systems design. But it seemed like no matter what I was working on, it always centered around communication and control. That's actually how I got into industrial Ethernet, and I branched out into, from protocols like MIL standard 1553 and Airing 429 to other serial-based protocols like Profibus and Modbus. And of course, that naturally led to PROFINET and the other Ethernet-based protocols. I also spent quite a few years developing time-sensitive networking solutions. But now I focus specifically on PROFINET and its related technologies. And so with that, I will jump into the presentation here. And now that you know a little bit about me, let me tell you a little bit about our organization. We are Profibus and Profinet International, or PI for short. We are the global organization that created Profibus and Profinet, and we continue to maintain and promote these open communication standards. The organization started back in 1989 with Profibus, followed by Profinet in the early 2000s. Next came IO-Link, a communication technology for the last meter, and that was followed by Omlox, a communication technology for wireless location tracking. And now, most recently, MTP or module type package. And this is a communication technology for easier, more flexible integration of process automation equipment. Now, we have grown worldwide to 24 regional PI associations, 57 competence centers, 8 test labs, and 31 training centers. It's important to remember that we are a global organization because if you're a global manufacturer, chances are there's PROFINET support in the country in which you're located, and you can get that support in the country's native language. In the lower right part of the slide here, we are showing our technologies under the PI umbrella. And I really wanted to point out that these technologies, all the technologies within PI umbrella, are supported by a set of working groups. And these working groups are made up of participants from member companies, and they are the ones that actually create and update the various standards and specifications. Also, any of these working groups are open to any member company. So PI North America is one of the 24 regional PI associations, and we were founded in 1994. We are a nonprofit, member-supported organization where we think globally and act locally. So here in North America, we are supported by our local competence centers, training centers, and test labs. And competence centers provide technical support for things like protocol, interoperability, and installation type questions. Training centers provide educational services for things like training courses and hands-on lab work. And test labs are, well, just that. They are labs that provide testing services and device certification. So any member company can be any combination of these three. You can see here, if you're looking at the slide, that the Profi Interface Center is all three, where we have JCOM Automation is both a competence center and a training center. And here in North America, we are pleased to have HMS as a training center and Phoenix Contact also as a competence center. Now, one thing I would like to point out to everyone is that what you should be aware of is that every PROFINET device must be certified. So if you make a PROFINET device, you need to go to a test lab to get it certified. And here in North America, you certify devices at the Profi Interface Center. So I think it's important to begin our discussion today by talking about the impact digital transformation has had on factory networks. There has been an explosion of devices in manufacturing facilities, and it's not uncommon for car manufacturers to have over 50,000 Ethernet nodes in just one of their factories. Large production cells can have over 1,000 Ethernet nodes in them. But the point is that all of these nodes increase the amount of traffic automation devices must handle. It's not unrealistic for a device to have to deal with over 2,000 messages while it's operating, while it's trying to do its job. And emerging technologies like automated guided vehicles add a level of dynamics to the network architecture because they're constantly entering and leaving various production cells located in different areas of the factory. And of course, as these factories become more and more flexible, networks must support adding and removing devices while the factory is operating. And so in response to this digital transformation, we have gone from rigid hierarchical systems using field buses to industrial Ethernet-based networks where any device can be connected to any other device. This means devices at the field level can be connected to devices at the process control level, the production level, even the operations level and above. But this doesn't mean that the requirements for determinism, redundancy, safety, and security are any less on a converged network. It means you need to have a network technology that supports these requirements, and this is where PROFINET comes in. So to understand PROFINET, I think it's instructive here to start with the OSI model, since the OSI model defines networking. And of course, Profinet is a networking technology. The OSI model is divided into 7 layers, as I'm sure we are all familiar with by now, starting with the physical layer. And this is where we get access to the wire and turn electrical signals into bits. Layer 2 is the data link layer, and this is where we turn bits into bytes that make up an Ethernet frame. Layer 3 is the network layer, and this is where we turn Ethernet frames into IP packets. So I like to think about Ethernet frames being switched around a local area network and IP packets being routed around a wide area network like the internet. And so the next layer up is the transport layer, and this is where we turn IP packets into TCP or UDP datagrams. These datagrams are used based on the type of connection needed to route IP packets. TCP datagrams are connection-based, and UDP datagrams are connection-less. But really, regardless of the type of connection, we typically go straight up to layer 7, the application layer. And this is where Profinet lives, along with all the other Ethernet-based protocols you may be familiar with, like HTTP, FTP, SNMP, and so on. So then what exactly is Profinet, and what challenges is it trying to overcome? The most obvious challenge is environmental. We need to operate in a wide range of harsh environments. And obviously, we need to be deterministic, meaning we need to guarantee data delivery. But we have to do this in the presence of IT traffic or non-real-time applications like web servers. We also can't operate in a vacuum. We need to operate in a local area network and support getting data to wide area networks and up into the cloud. And so to overcome these challenges, Profinet uses communication channels for speed and determinism. It uses standard unmodified Ethernet so multiple protocols can coexist on the same wire. We didn't have this with field buses, right? It was one protocol, one wire. But most importantly, Profinet is an OT protocol running at the application layer so that it can maintain real-time data exchange, provide alarms and diagnostics to keep automation equipment running, and support topologies for reliable communication. So we can think of Profinet as separating traffic into a real-time channel and a non-real-time channel. That's messages with a particular ether type that's actually 8892, and the number doesn't matter, but the point here is that the real-time channel is where all Profinet messages with that ether type go into. And any other ether type, they go into the non-real-time channel. So we use the non-real-time channel for acyclic data exchange. And we use the real-time channel for cyclic data exchange. So cyclic data exchange with synchronization, we classify this as time critical. And without synchronization, it is classified as real-time. But really the point here is that this is how we can use the same standard unmodified Ethernet for Profinet as we can for any other IT protocol. All messages living together, coexisting on the same wire. So we take this a step further here and look at the real-time channel and the non-real-time channel. And these are combined together into a concept that we call an application relation. So think of an application relation as a network connection for doing both acyclic and cyclic data exchange. And we do this between controllers and devices. This network connection consists of 3 different types of information to be exchanged, and we call these types of information communication relations. So on the lower left part of the slide, you can see here that we have something called a record data communication relation, and it's essentially the non-real-time channel for acyclic data exchange to pass information like configuration, security, and diagnostics. The I/O data communication relation is part of the real-time channel for doing this cyclic data exchange that we need to do to periodically update controller and device I/O data. And finally, we have the alarm communication relation. So this is also part of the real-time channel because what we need to do here is it's used for alerting the controller to device faults as soon as they occur or when they get resolved. Now, on the right part of the slide, we can see some use cases for application relations, and these use cases are either a single application relations for controller to device communication, and we have an optional application relation here for doing dynamic reconfiguration. We also use an application relation for something we call shared device. And of course, why we are here today and talking about applications relations is actually because of system redundancy. And so we'll get into these use cases in more detail here in a moment. But first, I wanted to point out that when we talk about messages being non-real-time, real-time, or time-critical, what we're really doing is specifying a level of network performance. Non-real-time performance has cycle times above 100 milliseconds, but we also use this term to indicate that a message may have no cycle time at all. In other words, acyclic data exchange. Real-time performance has cycle times in the 1 to 10 millisecond range, but really that range can extend up to 100 milliseconds. So time-critical performance has cycle times less than a millisecond, and it's not uncommon to have cycle times around 250 microseconds or less. Most applications are either real-time or non-real-time, while high-performance applications are considered time-critical. These applications use time synchronization to guarantee data arrives exactly when needed, but we also must ensure that the network is open to any Ethernet traffic. So in order to achieve time-critical performance here, and we do this for the most demanding applications like high-speed motion control. And so what we did is we added 4 features to basic Profinet here, and we call this Profinet isochronous real-time or Profinet IRT. These added features are synchronization, node arrival time, scheduling, and time-critical domains. Now, IRT has been around since 2004, but in the future, Profinet will move to a new set of IEEE Ethernet standards called time-sensitive networking, or TSN. Profinet over TSN will actually have the same functionality and performance as Profinet IRT, but will be able to scale to faster and faster networks and as bandwidth is increasing. So this chart shows the differences between Profinet RT, IRT, and TSN. And the main difference is obviously synchronization and these other features that guarantee data arrives exactly when needed. Notice under the Profinet IRT column here that the bandwidth for Profinet IRT is 100 megabits per second. And the bandwidth for Profinet RT and TSN are scalable. Also, for those device manufacturers out there looking to add Profinet IRT to their products, there are lots of ASICs and other solutions available in the market with IRT capability. All right, so let's take a minute here to summarize all of this. We have a single infrastructure for doing real-time data exchange along with non-real-time information exchange. Profinet uses the same infrastructure as any Ethernet network. Machines that speak Profinet do so using network connections called application relations, and these messages coexist with all other messages, so information can pass from devices to machines to factories to the cloud and back. And so if you take away nothing else from this podcast today, it is the word coexistence. Profinet coexists with all other protocols on the wire. So let's start talking a little bit here about the main topic, system redundancy, and why we got into talking about Profinet at all, right? I mean, why do we need system redundancy and things like application relations and dynamic reconfiguration? Well, it's because one of the things we're pretty proud of with Profinet is not only the depth of its capabilities, but also the breadth of its capabilities. And with the lines blurring between what's factory automation, what's process automation, and what's motion control, we are seeing all three types of automation appearing in a single installation. So we want to make sure Profinet meets requirements across the entire range of industrial automation. So let's start out here by looking at the differences between process automation versus factory automation, and then we'll get into the details. First off, process signals typically change slower, on the order of hundreds of milliseconds versus tens of milliseconds in factory automation. And process signals often need to travel longer distances and potentially into hazardous or explosive areas. Now, with process plants operating 24/7, 365, systems must provide high availability and support changes while the plant is in production. This is where system redundancy and dynamic reconfiguration come in. We'll discuss these again here in just a minute. I just wanted to finish off this slide with saying that an e-stop is usually not possible because while you can turn off the automation, that's not necessarily going to stop the chemical reaction or whatever from proceeding. Sensors and actuators in process automation are also more complex. Typically, we call them field instruments. And process plants have many, many, many more I/O, tens of thousands of I/O, usually controlled by a DCS. And so when we talk about system redundancy, I actually like to call it scalable system redundancy because it isn't just one thing. This is where we add components to the network for increasing the level of system availability. So there are four possibilities: S1, S2, and R1, R2. The letter indicates if there are single or redundant network access points, and the number indicates how many application relations are supported by each network access point. So think of a network access point as a physical interface to the network. And from our earlier discussion, think of an application relation as a network connection between a controller and a device. So you have S1 has single network access points, right? So each device has single network access points with one application relation connected to one controller. S2 is where we also have single network access points, but with two application relations now connected to different controllers. R1 is where we have redundant network access points, but each one of these redundant network access points only has one application relation, but those are connected to different controllers. And finally, we kind of go over the top here with R2, and here's where we have redundant network access points with two application relations connected to different controllers.
I want to just stop here and talk about S2. And for the people who are listening, which I know is about a quarter of you guys out there, think of S2 as you have a primary controller and a secondary controller. If you're seeing the screen, you can see I'm reading the slide, but you have your two primary and secondary controllers, right? So you have one of each, and primary controller has the application one, and secondary has application resource number two. And each device that's connected on the Ethernet has both the one and two. So maybe you have a rack of I/O out there. It needs to talk to both the primary controller and the secondary controller. And so to me, that is kind of like your classic redundant PLC system where you have two PLCs and you have a bunch of I/O, and each piece of I/O has to talk to both the primary and the secondary. So if the primary goes down, the secondary can take over. And so I think that's why there's so much interest in S2, because that kind of is that classic example. Now, Tom, let me turn it back to you. Would you say I'm right on that, or?
Oh, spot on. I mean, I think it's great, and really kind of emphasizing the point that there's that one physical connection on the network access point, but now we have two connections in that physical access point there, right? So you can then have one of those connections go to the primary controller and the other one to the secondary controller. And in case one of those controllers fails, the device still can get the information it needs. Perfect. So yeah, that's how we do that. And just a little bit finer point on R1, if you think about it, it's S2, but now all we've done is we've split the physical interface. So one of the physical interfaces has one of the connections, and the other physical interface has the other connection. So you really kind of have the same level of redundant functionality here, backup functionality with the secondary controller, but here you're using multiple physical interfaces.
Now, let me ask you about that. So as I look at R1, right, it seems like they connect to port, I'll just call it port 1 on each device to switch number 1, which in this case would be the green switch, and port number 2 of each device to the switch number 2, which is the blue switch. Would that be typical to have separate switches, a different switch for each port?
It doesn't have to, right? Okay. I think we chose to show it like this for simplicity, kind of to try to emphasize the point that, okay, here's the second port going to the secondary controller. Here's the first port going to the primary controller. And we just wanted to emphasize that point because sometimes these diagrams can be a bit confusing.
And you may have an application that doesn't require redundant switches, depending on maybe the MTBF of the switch itself, or your failure mode on your I/O. Okay, I'm with you. Go ahead.
Yeah. Good. All right. So I think that's some excellent detail on that. And so if you wouldn't mind or don't have any other questions, let's move on to the next slide. So you can see in that previous slide how system redundancy supports high availability by increasing system availability using these network access points and application relations. But we can also support high availability by using network redundancy. And the way Profinet supports network redundancy is through the use of ring topologies, and we call this media redundancy. The reason we use rings is because if a cable breaks or the physical connection somehow breaks as well, or even a device fails, the network can revert back to a line topology, keeping the system operational. However, supporting network redundancy with rings means we can't use protocols typically used in IT networks like STP and RSTP. And this is because STP and RSTP actually prevent network redundancy by blocking redundant paths in order to keep frames from circulating forever in the network. And so in order for Profinet to support rings, we need a way to prevent frames from circulating forever in the network. And to do this, we use a protocol called the Media Redundancy Protocol, or MRP. MRP uses one media redundancy manager for each ring, and the rest of the devices are called media redundancy clients. Managers are typically controllers or Profinet switches, and clients are typically the devices in the network. So the way it works is this. The manager periodically sends test frames around the network here to check the integrity of the ring. If the manager doesn't get the test frame back, there's a failure somewhere in the ring. And so the manager then notifies the clients about this failure, and then the manager sets the network to operate as a line topology until the failure is repaired, right? And so that's how we can get network redundancy with our media redundancy protocol. All right, so now you can see how system redundancy and media redundancy both support high availability. System redundancy does this by increasing system availability, while media redundancy does this by increasing network availability. Obviously, you can use one without the other, but by combining system redundancy and media redundancy, we can increase the overall system reliability. For example, here we are showing different topologies for S1 and S2. And these are similar to the topologies that were on the previous slide. So if you notice here that for S1, we can only have media redundancy because there isn't a secondary controller to provide system redundancy. S2 is where we combine system redundancy and media redundancy by adding an MRP ring. But I wanted to point out here that even though we're showing this MRP ring as a possible topology, there really are other topologies possible. It really depends on the level of system reliability you're trying to achieve. And so likewise on this next slide here, we are showing two topologies for adding media redundancy to R1 and R2. And so for R1, we've chosen, again, probably for simplicity's sake, we add an MRP ring for each redundant network access point. For R2, we do the same thing here. We also have an MRP ring for each redundant network access point, but we also add a third MRP ring for the controllers. Now, this is really just to try to emphasize the point that you can really come up with just about any topology possible, because it really depends on the number of ports on each device and the number of switches in the network, and again, your overall system reliability requirements. So in order to keep process plants operating 24/7, 365, dynamic reconfiguration is another use case for application relations. And so this is where we can add or remove devices on the fly while the plant is in production. Because if you think about it, typically when there is a new configuration for the PLC first has to go into stop mode. It needs to then receive the new configuration, and then it can go back into run mode. Well, this doesn't work in process automation because we're trying to operate 24/7, 365. So with dynamic reconfiguration, the controller continues operating with its current application relation while it sets up a new application relation, right? I mean, again, it's really trying to get a new network connection established. So then the controller then switches over to the new application relation after the new configuration is validated. Once we have this validation and the configuration's good, the controller removes the old application relations and continues operating all while staying in run mode. Pretty handy stuff here for supporting high availability. Now, one last topic regarding system redundancy and dynamic reconfiguration. Because these two Profinet capabilities are compatible with a new technology called single pair Ethernet. And this provides power and data over just 2 wires. This version of Ethernet is now part of the IEEE 802.3 standard, referred to as 10BASE-T1L. So 10BASE-T1L is the non-intrinsically saved version of 2-wire Ethernet. To support intrinsic safety, 10BASE-T1L was enhanced by an additional standard called Ethernet APL, or Advanced Physical Layer. So when we combine Profinet with this Ethernet APL version of 10BASE-T1L, we simply call it Profinet over APL. It not only provides power and data over the same 2 wires, but also supports long cable runs up to 1 kilometer, 10 megabit per second communication speeds, and can be used in all hazardous areas. So intrinsic safety is achieved by ensuring both the Ethernet signals and power on the wire are within explosion-safe levels. And even with all of this, system redundancy and dynamic reconfiguration work seamlessly with this new technology we call PROFINET over APL. Now, one thing I'd like to close with here is a final thought regarding a new technology I think everyone should become aware of here, and it's emerging in the market. It's quite new, and it's a technology called MTP, or Module Type Package. And so this is a technology being applied first here to use cases considered to be a hybrid of both process automation and factory automation. So what MTP does is it applies OPC-UA information models to create standardized, non-proprietary, application-level descriptions for automation equipment. And so what these descriptions do is they simplify the communication between equipment and the control system. And it does this by modularizing the process into more manageable pieces. So really, the point is to construct a factory with modular equipment to simplify integration and allow for better flexibility should changes be required. Now, with the help of the process orchestration layer and this OPC-UA connectivity, MTP-enabled equipment can plug and operate, reducing the time to commission a process or make changes to that process. This is pretty cutting-edge stuff. I think you're going to find and hear a lot more about MTP in the near future. All right, so it's time to wrap things up with a summary of all the resources you can use to learn even more about PROFINET. One of the things you can do here is you can get access to the PROFINET one-day training class slide deck by going to profinet2025.com, entering your email, and downloading the slides in PDF format. And what's really handy is that all of the links in the PDF are live, so information is just a click away. We also have our website, us.profinet.com. It has white papers, application stories, webinars, and documentation, including access to all of the standards and specifications. This is truly your one-stop shop for locating everything about PROFINET. Now, we do our PROFINET one-day training classes and IO-Link workshops all over the U.S. and parts of Canada. So if you are interested in attending one of these, you can always find the next city we are going to by clicking on the training links at the bottom of the slide.
Hey guys, Shawn here. I just wanted to jump in for a minute for the audio audience to give you that website. It's us.profinet.com/ODTC, or Oscar Delta Tango Charlie. So that's the website. And I also went and pulled up the website, which if you're watching, you can see here. But for those listening, these one-day PROFINET courses are coming to Phoenix, Arizona, August 26th, Minneapolis, Minnesota, September 10th, Newark and New York City, September 25th, Greenville, South Carolina, October 7th, Detroit, Michigan, October 23rd, Portland, Oregon, November 4th, and Houston, Texas, November 18th. So with that said, let's jump back into the show.
Now, one of our most popular resources is PROFINET University. This website structures information into little courses, and you can proceed through them at your own pace. You can go lesson by lesson, or you can jump around. You can even decide which course to take based on a difficulty tag. Definitely make sure to check out this resource. We do have lots of great webinars on the website, and they're archived on the website. Now, some of these webinars, they rehash what we covered today, but in other cases, they expand on what we covered today. But in either case, make sure you share these webinars with your colleagues, especially if they're interested in any one of the topics that we have listed on the slide. And finally, the Certified Network Engineer course is the next logical step if you would like to dive deeper into the technical details of PROFINET. It is a week long in Johnson City, Tennessee, and it features hands-on lab work. And if you would like us to provide training to 8 or more students, we can even come to your site. If you would like more details about any of this, please head to the website to learn more. And with that, Shawn, I think that is my last slide, and covered the topics that I think we wanted to cover today.
Yeah, and I just want to point out there too, guys, this training goes out through all around the U.S. I definitely recommend getting up there if you're using Profinet and you want to get some training. They usually fill the room like, 50 to 100 people. And it's, they do this every year. So check those dates out. If you need to get some hands on with Profinet, I would definitely check out those. And of course, we'll have all the links in the description. I also want to thank Tom for that slide, really defining S1 versus S2 versus R1 and R2. A lot of people say we have S2 compatibility. As a matter of fact, we're going to be looking at some products that have S2 compatibility here in the future. And, just trying to understand what that means, right? When somebody just says S2, it's like, what does that mean? So
Yeah.
that slide really doesn't, for you guys listening, I thought that slide really kind of lays it out, kind of gives you like, all right, this is what it means. And so from my perspective, that's like it's you supporting redundant controllers, right? And so if you have an S2 setup of redundant Siemens controllers or CPUs, then that product will support that. And that's important, right? Because if you had a product that didn't support it, it's not going to work with your application. So I thought that, and the Ethernet APL is such a big deal in process because the distance, right, and the fact that it's intrinsically safe and supports all those zones and areas and whatnot. That is, and everybody, all the instrumentation people are all over, right? The Rosemonts, the Fishers, the Endress houses, everybody is on that working group. We've covered that on the news show many times, and just very interesting to see where that goes. But I think it's going to take over that part of the industry. So, but Tom, was there anything else you wanted to cover in today's show?
No, I think that really puts a fine finale on this here. I do wanted to maybe emphasize that that point about network redundancy being compatible with system redundancy. So you can really hone in on what your system reliability requirements are, and also with this Profinet over APL piece of it, completely compatible with Profinet in of itself, and also you don't have to worry about it not supporting system redundancy or anything of the like. Whether you wanted to get redundant, even redundant devices out there. So that's I think that's about it.
All right. Well, again, Tom, thank you so much for coming on. We look forward to trying out some of these S2 Profinet devices in the near future. But with that, I really wanted to have you on first to kind of lay the groundwork for us and really appreciate it.
No problem. Thank you for having me.
Well, I hope you guys enjoyed that episode. I did. I enjoyed sitting down with Tom, getting up to date on all those different products. And it's great to know that they have all these free hands-on training days coming across the United States. And, what a great refresher from the original 2020 presentation that we had somebody from Siemens do. So I really appreciate Tom coming on. And speaking of Siemens, so thankful they sponsored this episode so we could really sit ad-free and make the video free to everybody. Please, if you see Siemens or any of the vendors who sponsor our episodes, please tell them a thank you from us. It really helps us keep the show going. Speaking of keeping the show going, just a reminder, if you're a student or a vendor, price increases will hit mid-September. So if you're a student, you want to buy another course, now's the time to do it. If you're a vendor and you have an existing balance, you will want to schedule those podcasts before mid-September or else you'll be subject to the price increase. So with that said, I also want to remind you, I have a new podcast, Automation Tech Talk. I'm reusing the old Automation News Headlines podcast. So if you already subscribed to that, you're just not getting the new show for free. It's also on the Automation blog, on YouTube, on LinkedIn. So I'm doing it as a live stream every lunchtime, just talking about what I learned in that last week, little tidbits here and there. And I want to hear from you guys too. As a matter of fact, I already had Giovanni come on and do an interview with me. So at one point I'll schedule that as a lunchtime podcast for Automation Tech Talk. Again, it still shows up as Automation News Headlines, I think. So at some point I'll have to find time to edit that to change the name. But in any case, with that, I think I've covered everything. I want to thank you guys for tuning in. Really appreciate you. You're the best audience in the podcast world. or the video world, whatever you want to look at it as. But I really appreciate you all. Please feel free to send me emails, write to me, leave comments. I love to hear from you guys. And I just want to wish you all good health and happiness. And until next time, my friends, peace.